Okay, welcome. This is going to be the explanation of all the answers for the Year 10 Science exam. I'll go through this as quick as I can, why the answers were the way that they were, and also how to actually approach these questions for the future. Okay, so number one, what is not considered evidence of evolution? Well, this is evidence of tails and gills, so that's probably likely embryonic similarity. Distant species have similar hand structures. Well, they've evolved to have similar function. C would be the fossil record. D, this last one here, it's one that least likely makes sense. Technically, you could argue for any of them, but D is the least likely to make sense. And this is a recurring theme that you'll see a lot in biology questions. Pick the most obvious answer. None of them are trying to trick you. Okay, number two, which is an example of natural selection. So with natural selection here, it needs to be about a non-human intervened event. Selecting for specific traits. This was an extremely tricky question, very wordy, very hard. We can straight away cross out this one because we know that that's humans going for desired characteristics. And B and C will also not be correct because these two are both random events and they are just randomly wiping out a selection of the population without selecting for traits. Now, in this case, it's going to be A because even though pesticide is not considered natural, it is not a desired trait. Humans did not go and do this purposefully. Humans did not put the pesticide in there to make the animals have the desired trait. But the so-called stronger or fitter genes survived. Okay, that was a really, really tricky one. Okay, number three, this is about appropriate evidence to determine if speciation has occurred. And so as soon as you see speciation, you know it's two different species have evolved, have happened. Okay, so the first one here, breeding between pairs consistently results in non-viable offspring. Okay, so that means that's basically the definition of a species. Sorry, the opposite of a definition of a species. So it may not be that one. They inhabit vastly different habitats. Well, that's not necessarily true because species of the same and of different species can inhabit different habitats. They have recognizable distinct features, etc., etc. Well, that's not necessarily true either because we know that two animals of the same species can have the same features. For instance, if you consider a male and a female anglerfish, they are hugely different size, body shape, body structure, but they're the same species. Probably not that one. Their DNA sequences are non-identical. So that's not really enough either because you and I are the same species, but our DNA sequences, the entirety of them are non-identical. You know, we've got that little 0.5% difference between you and me. So this is the best one here. When it comes to speciation, this is really the only and most valid test that speciation has occurred, is when the individuals from one species and another cannot produce fertile, viable offspring. That's the key one. Okay. Which of the following forms of evidence would be the best determinant of species, common ancestor? Okay, so this one's about having a common ancestor. Okay, so this is about degree of relatedness, how closely related two things are. So distribution of habitat, no, because you might find grass all over the world, still the same species. Similarities in physical characteristics, hair size, color, etc. Possibly not strong enough as well for the same reason. High percentage of matching DNA sequences. That is probably likely the best one so far. Similarities in hunting behavior. Well, probably not that one either because, predators tend to have similar hunting. Doesn't mean that they're all related. DNA is going to be your most valid test here. Okay, how do fossils support the theory of evolution? All right. So just a reminder, fossils are basically a graduation of physical changes over time, where the most recent organisms are at the top, the oldest at the bottom. And the idea is that you can see a slow gradual change from newest to oldest, the further back you go in the fossil record. That's what we're looking for here. Okay, so comparing layers of fossilized remains shows a gradual change in features over time. I'm just going to go for that one straight away. Okay, the organisms in the fossil record are identical. No, only organisms with rigid structures such as skeletons have been preserved. That is somewhat true, but it doesn't actually relate to our question. The fossil record shows a sudden burst of fossilized organisms all at the same time. Again, that could be possibly true, but doesn't relate to our question. Okay, let's go to the next page. Okay, so this structure here is called a cladogram. It's not necessarily a familiar structure to you, but something that you should be able to interpret. So without even looking at the question, each of those are species or organisms, A, B, C, D, E. And what we're showing here is a branching, where the more closely connected, the more closely related they are. So an evolutionary tree. So what we're going to try and pick here is something that is incorrect. So the first one, species A, closest relative is species B. That's true. We're not going to pick that one. A fork represents speciation. Yeah, that would be true, because as they fork off or branch off from each other, new species has evolved. Otherwise, they keep staying down the same line. A, B, C, D, E share a common ancestor. Absolutely, they do. And that would be true for any species. All species on the planet, all of them share a common ancestor. Species D is more closely related to species E than A. So D. Is it more closely related to E? Well, how would we actually figure this out? What we're going to do is start from the very start, so the original common ancestor, and branch off. So let's start here. So first off, E branches off. Then we keep going. Then D branches off. At the same time, A is branching off. So this is where D and A branch off. But this is where D and E branch off. So we know for a fact that D is more closely related to A than it is E. Okay, that is the biology bit done. Okay, so fuel is burnt straight away. We know it's combustion. Fuel, burning, producing oxygen and carbon dioxide, producing water and carbon dioxide. That is always going to be combustion. And acid and a base, we know straight away it's going to be neutralization. It's sometimes also called an acid-base reaction, but here we've just got neutralization. Okay, so this is a pH indicator. Again, you may have never seen this before. That will actually not be very helpful to you. But the idea here is that we have 7 neutral in the middle. We have our super acidic stuff on the far left. So things like lemon juice. And then we have our basic or alkaline stuff in the high numbers. So think things like soap, etc., etc. How do I get my little thing back? Doesn't matter. Yeah, so what we're looking for. In a neutral solution, the color will be closest to, we're looking at number 7 here, and it's got to be green. Okay. The burning of a fuel, straight away it's combustion, produces carbon dioxide gas and water vapor is an example of. Okay. So we're not looking for a type of reaction here. We're looking for exothermic, etc. So exiting is releasing heat. Exiting heat. Endo, into, enter is retaining heat or absorbing heat. We know when we're burning a fuel, that's burning, that's producing heat. So we know we're looking for an exothermic reaction. An exothermic reaction releases heat, doesn't absorb it. Exo, release. Okay. All right, now let's have a little look here. I may have to pause to do calculations to not take up too much of your time, but blah, 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 blah. Okay, the distance, here is a map. It's about interpreting the map. So the distance Unreality has traveled, and Unreality lives in house 1. By the time she gets home is, so she lives in house 1. Her best friend, Impossible Jones, lives in house 2 on Pretend Road. Smith and Jones, let's call them that. One afternoon, Unreality walks from her house to Impossible's house to have coffee. This walk takes her 5 minutes. She sits with her friend for 2 hours, then takes 2 minutes to walk home. Okay, so we're assuming that she's walking along these straight lines. So she's walking along here, here, and here. So there are 3 sections of the road there. So she's walked 200 plus 100 plus another 200. That equals 500. And then she's back home again. So because she's just returning the journey, so that's that. Her displacement by the time she gets home, well, she's just getting home again, so it's 0 because she has made no total or gross distance. Okay, the car is traveling at a speed of 90 kilometers an hour. In 1 second, the car will travel, oh gosh. So we want to convert 90 kilometers per hour to meters per second. And we do that by dividing 90 by 3.6. Let me just pause. So I just use my calculator, and that is 25 meters per second. So the rate or the speed is 25 meters per second, meaning that in 1 second, she will have traveled 25 meters. Okay, now the engine of this has a force. So straight away with my question, what I like to do is I like to underline my things. That's mass. the force that's produced is 9,000 newtons. That's big F. The maximum acceleration, okay, so we're trying to find acceleration. I go to my little thingy, my formula sheet, and see what I have. So the formula I know is force equals mass times acceleration, meaning, let's do my little triangle here, force on top, mass times acceleration. I cover up acceleration, which is the thing I want to find, and then I look at the relationship between the two. So force is on top of mass. Acceleration equals force over mass, 9,000 divided by 4,500, and that will just equal 2. When we're doing acceleration, it's meters per second squared is the unit. Yep, it's right there. Perfect. Okay. So much physics. Okay. So the acceleration due to gravity on Earth is 9.8. Well, on the moon, it is 1.6 g with little m, g with little e. This means that you would have less mass on the moon. No, mass doesn't change. Mass is constant. The same mass on and weight on Earth and on the moon. No, because we know that weight is obviously going to change. Less weight on the moon. That's true. So in physics, here is a simple idea. Weight is simply gravity. Weight very much is the force of gravity. We measure mass in things like grams and kilograms because that is a measurement of material or matter or atomic stuff. Weight, when you do physics, you actually measure it in newtons because weight is simply a measure of how much gravity, the force of gravity exerts on your mass. Weight is gravity. They are the same thing, physically speaking. The inertia of an object. So we know that's the tendency of an object to resist a change in motion. So it's not distance covered. It's not rate the change of speed. It's not its mass. It is the tendency of an object to maintain its state of motion. So when you're sitting still, just like when you're lying in bed, it's hard to get up. You want to maintain that. But when you're working and doing stuff, you kind of want to keep going. That's what inertia is. We all have it. Which graph shows an object that is accelerating as time passes? Okay, so we know it's not this. And we know it's not this. Speed is the same for A, and the distance, it is actually stopped in D. Okay, so is it velocity or is it distance? Let's look at C. So for C here, as time goes by, the distance is slowly increasing. They're actually going at a constant rate. So they are going further away, but whatever point they are in the graph, they're going at a constant rate. That could be 1 kilometers an hour constantly. Whereas for number B, what we can see here is that over time, it's not the distance that's increasing, it's the velocity that's increasing. So it's definitely got to be number B. Remember, velocity is simply speed with direction. So when you see velocity, think speed. Okay, so what's happening here? So she's eating a pie, lifting it to her mouth. That's a distance, acceleration, blah, blah, blah. So the work she's done, etc., etc. So for this one, we actually, I believe, have to have 2 separate formulas. Let me just go back and check my, I just had to pull up my sheets again. So what have we got here? We have mass, we have distance, we have acceleration, we want to find work. Okay, so let me look at my formula sheet. The formula for work, I'll do on the left, I'll do in black, sorry. The formula for work is force times distance or displacement. Great, we have distance, but we don't have force. So what we need to go do first is go back and find a force formula that includes mass and acceleration, which we can find. So we know that from another formula, force equals mass times acceleration. So force equals 0.2 kilograms times acceleration, which is 0.1 meters per second, meaning that it's going to be 0.02 newtons. Great. So now we can go back to the work formula because now we've got our force, now we've got distance. So let's do the working out over here. So looking at the formula sheet, work equals force times displacement. Force is 0.02 from Formula 1 times displacement, which is 45 centimeters. And we know that it has to be in meters according to the formula here. I'm just double checking it is. Very good, very good. What did I say it was? 0.45. Okay, so that is 0.009, 0.009 joules. And have we got it there? Yes, we do. Thank goodness. Just doing that one in my head. Cool. So that is an example of something, a question that requires you to use two formulas. So it's a really good advice there to, in your exam test, whatever, highlight the bits of information you have, as I've done here. For instance, I've highlighted that 200 grams as the mass, meaning that when I go back to my formula sheet, I know exactly which formulas to find and look for. Okay, so the building up of greenhouse gases is all of this. So the building up of greenhouse gases increases global temperatures. Which one of the following statements best accounts for this phenomenon? So this is something that you guys know a lot with general knowledge. So it's the idea that various gases, for instance, carbon dioxide and methane, are produced in greater quantities than they normally would. They sit in the atmosphere. And that means when sun enters the Earth's atmosphere, it makes it harder to escape because there's basically more particles in the atmosphere. The sun's heat can't exit the atmosphere as easily due to all the extra particles. That's the answer that we're looking for here. Okay, so the amount of heat that leaves Earth's surface through atmosphere is increased. No, it's actually not more than that. The amount of heat that reaches Earth's surface through the atmosphere is increased. Look, I'm going to leave that there and explain why it's not that in a second. Heat reaches Earth's surface, and after it is reflected, so it is trapped in the atmosphere by the greenhouse gas. It is that one. Heat from the sun is reflected off the atmosphere. No, because it can still get into the atmosphere, so it's not that. So B is wrong because the amount of heat that reaches Earth's surface is the same. The sun itself is not being changed. It is the ability for heat to escape our atmosphere that is being affected by extra gas. It's pretty key there. Okay, which one of the following statements is not correct? So mass is the amount of material in an object. Yes, think mass, matter, material. So we know it's not that. Weight is the pull of gravity on an object. Yes, pull or force or whatever. I'm just going to leave that there. Weight is the mass of an object divided by the acceleration due to gravity. No, it's just not. The greater the mass of the body, the greater its, wait, let me just do that. The greater the mass of the body, the greater the inertia. That is absolutely correct. So that's not true. Okay, so let's look at these a little bit more closely. Weight is the pull of the gravity of an object. That is mostly right. Pull is not, yeah, pull, let's call it pull. Weight is the mass of an object. So let's write this pretend formula. Weight is the mass of an object divided by the acceleration due to gravity. No, it's not that. It's not that. If anything, it would be multiplied by, because your weight would increase with increasing gravity and increasing mass. So that formula would be closer to this. So cool. Next. Oh, let me just take a little break. Okay, so now we're heading into the short answer questions. So this is obviously a big exam. We've got 3 completely different subjects in there, bio, chem, and physics, all requiring quite different skills. Let's start with some advice about bio. So a lot of the questions you can see here are really only 1 mark. So although for a lot of you, you showed good information, what you really needed to show was specificity in your answers. And you really need to respond to the question being asked. So although you may write an answer that is true, like just in terms of content, it may not be enough to get that 1 mark. Okay, so for this question here, for example, it's asking why evidence is needed to support the scientific theory. So what a lot of us did was describe what a scientific theory is. For instance, a scientific theory is a working model of explanations to describe observable phenomena. Fantastic, true, and absolutely great thing about, that's great information, but not relevant to this question. So why is evidence needed? So sometimes when you're not sure about answers, what you can do is, what I like to do is I like to take it to an extreme or reverse it. So Why is evidence needed to support the theory of evolution? Well, I think of something that has a lot of evidence versus something that doesn't. For instance, list people has very little evidence versus something like evolution, which does. So I'd say without evidence, it's just a conspiracy or conjecture or guesswork. So I'd say no evidence is just a guess. There's actually no need to explain here the theory of evolution. You didn't actually need to make it about the theory of evolution itself. What you could have done if it was 2 marks, you could say, e.g., embryology supports concept of common ancestor. I wouldn't actually necessarily get a mark for that because it's only a 1 mark question, but there I provided a specific evidential example for evolution. But no evidence, it's just a guess. It's just conjecture. It's just conspiracy. So the structure and function of limbs, blah, blah, blah. So what is the term for similar structures that are observed between species of common ancestry? So that's the idea of things starting to have similar species and then branching out like this. So that would be, think of that image in class. So that would be, for instance, humans and horses both derive from a common mammal, and we both have 4 limbs. We both have 4 limbs. This here is homologous. So all we're looking for here is the word homologous. There's not a really good mnemonic device to remember the difference between homologous and analogous. For me, I think homologous is we all come from the same home. So all of us came from the same home and we branched out and we're now really different from each other. So the term for similar structures that are observed when they've adapted to similar environments but not have similar common ancestry would be analogous. So I know I said all species have common ancestry, but the idea here is not super recent common ancestry. So a good example for this could be something like a bat and a bird. One is a mammal, one is avian. So they aren't very closely related, but they both have wings because both of those structures have adapted for the same purpose. So think about it as different things sort of not coming together, but ending up having sort of mirroring structures. Analogous. Tricky. If you have some way to remember that, please let us know. So identify the evidence of evolution described above. So all you need to say here is, let's be even more fancy. Let's do it properly and say comparative embryology. Again, 1 mark, no need to describe embryology. No need to describe what embryology is. Just say that's the thing that it is. And clearly here we can see that 1, 2, 3, 4, all these different species look extremely similar in their structure and how different that they are when they're actually born. Okay, next page. Describe how the evidence in the diagram supports the theory of evolution. Okay, so now we're describing it. So what we'd say here is embryology shows the similarity in physical features between organisms or species, I should say. So similarity in physical features, that's 1 mark there. And this indicates a recent common ancestor. That's 2 marks. So evolution is all about having recent common ancestors. When a female horse, male donkey, the breeding pair results in a different type of animal known as a mule. Horse, donkey, different species. Mule, different species. Mules are healthy and reliable, but they cannot produce offspring of their own. So a mule is sterile and cannot make its own babies. It's not going to ever be successful as a species. What is meant by the term species? Okay, so let's be really specific about this. So a species is a group of organisms, and I'm going to talk a bit about this, whose breeding pairs can, not even consistently, can produce fertile offspring. Okay. So that is pretty much the one and only definition for a species. You can add some addendums to it by saying a group of organisms whose breeding pairs can consistently produce fertile, viable offspring. Okay. So what that means is that horses are species because horses within this group of people, within this group of organisms, can always produce babies that are fertile and viable. We need the fertile and viable bit because if the babies weren't fertile and viable, those genes will not be able to be carried on, and thus it would be pointless as a species. We say breeding pairs because obviously two people with male chromosomes or so-called male chromosomes can't necessarily produce. If there is a very older or very younger members of the species who are not sexually mature or past their sexual maturity, they obviously can't produce. We say can produce because, for instance, there might be, for instance, humans, great example, humans who are technically infertile, but the breeding pairs within their species, for instance, other couples within their species can produce offspring. So with a specific definition like this, it seems simple and it seems precise, but there is a lot else going on there, and your definition should account for that sort of stuff. So just saying group of organisms that can produce babies, not enough. Group of organisms that always produces babies, not true either. Consider humans that are sometimes infertile. So have a good understanding of what a species is. Okay, would a mule be referred to as a separate species from horses and donkeys? Yes. Yes. They cannot produce fertile offspring. So the question tells you that straight up, no mule can produce babies. So why would it be able to produce babies with horses or donkeys? To determine how similar horses, donkeys, and mules are, further testing can be completed. Identify the type of testing. So easy enough. You could do DNA. You could do compare proteins. That is probably the best. DNA is going to be your best answer there. DNA is going to be the most rigorous one after the, what's it called? The thingy. Yes. Okay. Let me just have a read of this because I'm just don't want to waste up too much of your time. Okay. So this is a classic example of a biology question that gives you like a big chunk of text and very little of it is actually relevant to your specific question. So the first term here is biodiversity. So life diversity, life variation. So what we're looking for here is the quantity, so number, quantity, and variety of species, not organisms, but species in an ecosystem or on Earth. Okay, so it's not just the number of species. For instance, you may have a type of grass. They're all slightly different genetically species, like 100 different types, but they're all very similar in structure, function, biological niche. That's not really diversity. It's quantity, but it's not really variety. Whereas, for example, you may have 100 species of finches who, you know, all live in a similar area, but they have a great difference in variety, like long beaks, short beaks, long tails, short tails, and they all serve different function structures. They sort of fit into the ecosystem in a different way. And it's got to be species here, not just organisms, because organisms could refer to just one single species. For instance, dogs. Dogs are one species, and every dog you meet is different because they all have very, very different physical and physiological and mental structures and abilities. So that would be a good answer there. It's a pretty nice definition. Describe the difference between natural selection and artificial selection here. Okay, so keep it brief. Artificial selection would be purposeful. You can make the sentence, you can make dot points, purposeful, human interfered, and specifically for a desired trait. Even if the only thing you say is artificial selection aims to bring about organisms with desired traits, desired characteristics, mention desired traits. Natural selection, I haven't done a full sentence, but you can see here the main point. Natural selection is when natural, or you can say environmental factors select for the fittest traits. And I like how a lot of you did fittest in things like this, because fittest doesn't mean strongest, best, fastest, prettiest, cutest, whatever. Fittest is literally fits best to that environment. So, you know, we may consider being really tall a really fit trait, but if that gets in the way of you squeezing through holes, it's not the fittest to that environment. It's a really simple example, but there you go, fittest. So, you know, that term you've heard all the time, survival of the fittest, is not about strongest, best, smartest, whatever. It's about whatever trait has the best. And, you know, we see it all the time in humans, not necessarily strongest, biggest, prettiest. It could be the ones who are best at computer programming, the ones that are the best at hoarding seeds or seeing patterns, you know, when our eventual apocalypse comes. Identify if a natural selection or artificial selection is more important for maintaining biodiversity. Okay, so just as an example here, humans are really great at this one thing called monoculture or permaculture. If you drive through the country, you'll see vast swaths of land which are just one thing: monoculture, corn, rice, soy, whatever, and cows. This is what we do when we decide we want the cow with the biggest muscles so we can extract the most meat from it. This is what we do when we decide we want the most highest yielding corn because we want to produce the most grain and soy. So artificial selection, absolutely not. Natural selection, and right out the word, I'm just being lazy. Natural selection as the organisms whose traits are selected for by the environment are best suited to that niche or ecosystem. Something along those lines. You could say other things like natural factors decide on a greater variety of different traits. Organisms respond better to the variety of different natural selectors that are in factor. You could also explain it with a comparison. You could say natural selection because in comparison, artificial selection produces monoculture and less diversity. Okay, last one. Identify zoos are competing their work using natural or artificial selection, blah, blah, blah. So we talked at the start about, for instance, giraffes and zebras receiving a nice environment. So obviously here it's going to be artificial selection. No, not necessarily obviously, but it's artificial selection. And the reason why is because although zoos are intending to do a good thing, they are intending to produce healthy offspring, healthy environment. The key thing here is that they still creating a desired trait. Whatever that desire is, creating a desired trait. And that trait could literally just be babies, healthy offspring. It is still a desire. Another reason it's 2 marks, so I'd actually, 1 mark for saying artificial, 1 mark for saying desired trait. I mean, I might just for the sake of it say no natural, so this would be the negative answer, no natural selection factors present. So there are no predators. There are, when they have diseases, they're treated. There is no lack of food source. So you can answer one of these questions in the positive, why, or the negative, not why. Okay, going straight onto it. So look at these 3 brothers. In a zoo, they'll probably survive and reproduce. Why? Because they have the perfect conditions. Explain why this would be different if they were relocated to wild giraffe populations. 2 marks here. So the zoo provides ideal, not even survival, I would say, ideal conditions to survive and reproduce. The natural habitat has more, and you could list a bunch of things. You could say more competition, predators, disease, more factors that could limit the chance of survival. So that's all right, 2-mark question. Out of the 3 brothers pictured above, which would be chosen as the fittest, give a reason for your answer. So again, it is the most suited to their environment. Why do giraffes have long necks? Long necks are suited to reaching tall trees. The middle giraffe is most suited to do this. That's all. You really got to pick just one giraffe there. It's just one. If it's 2, you're sort of not giving a clear answer. You're sort of fence sitting, which is not really accepted. Again, you could probably argue, oh, the middle one could probably get the medium trees, but no, the question's asking which of the 3, pick one and justify your response. It's not about saying, I can explain all my reasons why in a really good way. Write your responses in terms of the question. Okay, so there's 3 brothers share a mother and father. Explain why they're different heights. Okay, so this is that part of speciation, which is variation. So within any population, all members have okay, let's just write that down. Within, I'm going to do almost because we're not really talking about clone species. Within almost any population or species, natural variation exists due to genetic mixing, e.g. mother and father having different genes and those mixing together in different ways. Why do your brothers and sisters all have different hair, color, height, that sort of thing? Or you could even say, or not genetics, sorry, I said that, environmental factors. I know this is only 1 mark, but you could do either, e.g. nutrient availability. So we all know that if you don't have enough nutrients, you're not going to grow in the full way that you could have if you would. So 1 mark question, pick one of those and they'd be totally fine. The first one's better though. Genetics, we're doing genetics. Ooh, okay, chemistry, we're doing chemistry. So we're back to this pH indicator here. Amazing. So just reading the exact thing here. So milk, what is milk? Oh my God, milk is 6. It is green. Cola is 3. It is, how fast can I do this? Yellow. Toothpaste is 9. It is, let's call that cerulean. You're obviously going to say aqua or blue or teal. Vinegar 2 is orange. Bleach is 12. That is violet. And just say acid, neutral, or alkaline. Clearly, this question here, some of you thought that milk was neutral. It's not at least according to this diagram. And you may know in your head that milk is somewhat neutral, but this diagram very clearly puts it in the acidic section. So it has to be acidic. Cola, acidic, we know. Toothpaste, alkaline. Orange, acidic. And violet, alkaline too. Okay, so toothpaste is not a neutral substance, but blah, blah, blah. Explain why the use of toothpaste is great after consuming sugar, using cola as an example. Okay, sugar, e.g. cola, can harm teeth. You can say wear down enamel, whatever. That's more of a common knowledge thing. Sugar can harm teeth. But the main thing here is toothpaste. This is where you get the mark from. Toothpaste can neutralize the acidity in sugar. That would be the main point there. And you could, and then the inference here is that it minimizes acid wear or acid damage. Okay, so toothpaste has a pH level of 9. Let's remember again. So this is the exact same question. You can experience the health benefits of both products while having an overall more neutral substance in your mouth. Neutralization. Okay. Oh, God. Balancing equations. So we're looking for, the first one here is word equation and then So sometimes you wrote vinegar. Let's just, again, be specific to the question. Vinegar was acceptable here, but it specifically says, write the reaction between ethanoic acid and sodium hydroxide. Write ethanoic acid and sodium hydroxide. So just wrote it there, ethanoic acid. Make sure you've got your arrow in the middle. Make sure you've got your plus lines in the middle. Just make sure it's all spelled correctly. It's all in the word there. The next one, our favorite balancing equation. I will be back. I'm going to write down the chemical formula down the bottom and we're going to go through and balance it. Okay. So I've written it there to save time. So let's go through our steps. I'm just going to go and write down each thing. So I'm going to list sodium, calcium, carbon, hydrogen and oxygen on each side, just set up like this, NaCHO. And if you're wondering where I got all these formulas from, I only got them from the question. So it's ethanoic acid over here, plus sodium hydroxide, no, bicarb, that produces carbon dioxide, water, and a salt. So that is all the chemicals here. Let's go through and count each thing. So 1 sodium on this side, 1 sodium on the other. Carbon, 1, 2, and then there's a third little sneaky one there. So 3 on the left, 1, 2, 3 on the right as well. Hydrogens, 1, 2, 3, 4, 5. So 4 from the first one, 1 from the second. And then on the right-hand side, we've got 2 from the H2O and 3. Oh, this is looking good. And then oxygen, we've got 1, 2, 3, 4, 5 oxygens on the entire left-hand side. And then we've got 1, 2, 3. Oh, don't just love when that happens. I'm not going to be bothered writing that down. I'm just going to write that there. It's going to mark because it's fine. If vinegar is an acid, bicarb soda is a base. Oh, what? We know it's neutralization. We know neutralization is an acid plus a base produces a water and a salt. So salt isn't always sodium chloride. Salt can be potassium chloride. Salt can be this funny looking thing here. Salt is just a solid neutral substance. This one also happens to produce carbon dioxide, which is the fizzy stuff that we see when we're making our volcano reaction. Carbon dioxide is just the is the carbonated gas within the solution. Identify the evidence in the products that this type of reaction has occurred. Salt produced. It's only 1 mark. You can just say salt produced. You can also say neutral substance, water produced. It's 1 mark. Cool. Moving on. Another chemical thing. Okay, so let's have a little read through here and we'll talk about why and why. So popular car. Okay, so when we think car, straight away we think combustion. Let me just speed read this entire thing in 1 second. Oh, look, we've got a fuel burning in oxygen. It's producing carbon dioxide and water vapor. That is combustion. Always was. It's always going to be that. Okay, write a word equation. Okay, I'm just going to write it quickly. Okay, so let me explain each part. So with octane, yes, it's a fuel, but write octane. The question says octane, but use the word octane. It's type of fuel. It doesn't really say oxygen. Oh, it says air. Okay, it doesn't say oxygen, but you know that oxygen is the key, one of the key reactants in a combustion thing. So write oxygen. Air is a chemical compound with lots and lots of different things in there. So oxygen is the thing that we need here. Carbon dioxide is produced, obviously. And then the last thing is water vapor. So it can be water or water vapor. Whether water is in gas, liquid, or solid form, it's still water. So you don't need to write water vapor unless you really want to. Okay, so let's go through and write the balanced equation. I'm just going to set it up here. Wait a second. Okay, so this was a really tricky one. And I think the reason why is because it wasn't specified that oxygen was the input, and more specifically that whenever we're doing oxygen in chemistry, it's always O2. So it's one of the few chemical formulas that you really should remember. It's O2. So that stopped us a lot there. Okay, so just as we did in the previous slide, I'm going to write out for each. Going to set it up like this. Okay, so how many carbons on the left? 8. On the right, we have just 1. On the left-hand side, we have 18 hydrogens. And on the right, we just have 2. On the left, we have 2 oxygens. On the right, we have 1, 2, 3. Okay, so we have to do some balancing here. I'm going to use a different color just so I can see exactly what I'm doing. Now, advice about what to start with and what to end with. We know that we're going to end with the oxygen because the oxygen is the only thing by itself on the left-hand side, that O2. So that means that we can do that last, hopefully. What do we start with? Well, I personally like to leave hydrogen and oxygen to last just because they tend to be all over the place and everywhere. So I'm going to start with about doubling the carbons first. So how do I get 8 on the right-hand side? Well, I just put a little 8 in front of here. That means I've now got 8 carbons, but it also changes the number of oxygens I have. So I've now got 16 oxygens there, 8 times 2, plus that 1 there. So I've now got 17. Yikes, very annoying numbers here. Let's change a different color. So now I'm looking at the hydrogens. So 18 hydrogens on the left, 2 on the right. So what do? Put a 9 in front, that times that by 9, which makes that 18. Oh no, now we also have more oxygens. So let's count all over again. So we've got 16 oxygens from the carbon dioxide. And now we've got 9 here. So that is 25. Okay, so at least our carbons are balanced, at least our hydrogens are balanced. All we have to balance now is the oxygens. Let's go to green this time. All right. Here, what I'm going to do is a sneaky sort of mid-step. What do I multiply O2 by to get it from 2 to 25? Well, that number is actually 12.5. 12.5 times 2 is 25. Okay, so this is technically correct. But there's not really a such thing as half amounts of molecules, half numbers. So what we're going to do for our final answer, when I write it up the top here, is I'm going to double everything, and that will get rid of the half. So, and when I say everything, I mean everything. So let's bring this up to here, but let's double it. So now I have 2 molecules of octane. I have 25 molecules of oxygen. I have 16 molecules of carbon dioxide. And I have 18 molecules of water. That was a tricky one. It did take a bit longer. Not impossible, but longer. Just take care, just take time. Remember that oxygen is always O2. Come on. Okay, so older cars burn the same fuel, octane oxygen gas, but instead of producing carbon dioxide and water. I'm just not going to do that because I don't have space on this page. It uses the exact same method. Maybe I will. And if I rub this out, it'll ruin everything. Let's go to this one here. A catalytic converter has been installed in modern cars to reduce the amount of carbon monoxide. Why are the catalysts used in some reactions? Okay, so 1 mark. All that is catalysts speed up reaction rate. That is all you need for the mark. You can also say, if you're feeling nervous, without being used up as a reactant. That being used up as a reactant. Sorry about D there. I just can't really find the space for it in this document. Okay. Okay, so athletes eat carbs to get lots of energy. If athletes eat big meals, explain why chemical reactions need to be fast. All that is in order to quickly release energy from food. That's it. Otherwise, the food is just sitting around in the stomach, not being released, not being used. Explain the chemicals produced by the body to help increase the rate of the reaction. So we're looking for that biological catalyst, and that word is enzymes. So in the body, you have lots of enzymes that help further increase the rate of reaction. For instance, in your mouth, there is something called amylase. Anything with an A's on it is an enzyme. And this increases the rate of reaction of digestion of carbohydrates in the mouth. So remember that we use heat, reaction rate, and surface area to increase rate of reaction. So say you've got like a piece of cracker, the fact that your mouth is warm is going to increase rate of reaction. The fact that, you know, you've got cracker in there is going to increase rate of reaction. And the fact that you're chewing is going to increase surface area. Little proteins produced in your saliva help to break down that carbohydrate even further. So they're really important. One of the key nutrients that athletes need is glucose, sugar. Athletes consume glucose and interacts with oxygen, blah, 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 blah. Write a word equation for this chemical reaction. Okay, so I've just written the word equation there. Just use the words from the question, make it simple. Now let's do the balance equation down the bottom. Set it up, CHO. If this looks like a combustion reaction to you, it is. This is also known as cellular respiration. It is one of our body's main metabolic processes, breaking down of sugar with the oxygen that we breathe, produce carbon dioxide, and water, which is sweat and not sweat, sorry, water vapor from our mouths. So let's count it up. So how many carbons on the left? 6, and on the right, 1. Hydrogens on the left, 12, and on the right, 2. Oxygen on the left, 1, 2, 3, 4, 5, 6, 7, 8, and on the right, 1, 2, 3. Okay, let's use a different color and start doing some cancelling and crossing. Let's start with carbon and let's do oxygen last again because it is all by itself. So to get that 6 oxygen carbon on the right, 6 in front, that makes that one 6. That also changes the number of oxygen. So now I've got 12 oxygens here plus another one. That means I have a very pesky 13. That's fine. It'll balance out later, I'm sure. Now let's do our hydrogens. So the hydrogens on the left is 12, on the right it is 2. So we want to put 6 in front there. That will make that 12. And now we have 6 oxygens here. So 12 on the left plus 6 in blue. That means we've got 18. Okay, final step, hopefully. 6, 6, 6. So what do we need? How do we go from, that's a bit annoying. How do we go from 8 to 18? Okay, so what we've got here is we've got 6 oxygens from that first molecule on the left. We've got 2 here. So what number can we put in front of that O2 to make it altogether 18? We want to get 12 is what I'm basically saying. So let's put a 6 here. So now I've got 12 from that little bit, 6 from here. Now we've got 18. So that is your final formula there. 1 molecule of glucose, 6 of the O2, 6 of the CO2, and 6 of the H2O. Athletes are recommended to keep warm to maintain optimal levels. How can cooler reacted, blah. That's not word. Cooler temperatures decrease reaction rate. They do decrease reaction rate, and higher temperatures prevent reaction rates occurring. So there is a limit here. We've been saying that warmer temperatures increase reaction rate, but in all systems, including biological systems, there is a limit to how hot you can get something. In humans and most mammals, for example, we have very large tolerance to cold. We are really able to handle cold. We've got lots of physiological functions to look after that, but there is a pretty strict upper limit to how hot we can get without our body systems shutting down. So it's a narrow range. So encourage to eat slowly, chew their food. Why? Chewing increases surface area, which increases area for reactions to occur. It's just the difference between like having a big lollipop versus one you've crunched up into lots of bits. The one crunched up has more surfaces for the saliva to attack, etc., etc. We're almost there. My goodness gracious me. Oh my gosh. Okay, let's go into physics. This is our big fun science adventure. Okay, so first one is plane is going 250 kilometers an hour, traveling for 2 hours. How far is the plane traveled? I mean, just logically, we know that it's going to be 500 kilometers, or we can use our force, speed equals distance over time, meaning that distance is speed times time. Distance is 250 times 2, so 500 kilometers altogether. So make sure it's 500 altogether. Technically for a question like this, just putting the answer is fine, will be correct. And that's also the frustrating thing, is that even if you've done lots of great working out, but the answer is not correct, you can't necessarily get the mark. So that's why we recommend doing working out, because then you can backtrack and see what you've gotten wrong. It's also a good idea to underline or make really clear to the examiners what your final response is, because obviously in the thing it might get a bit all over the place. Underline, make it very clear, make it easy for the examiners to give you marks. We're always looking for marks, so make sure that they're there to be found. 500 kilometers, and also make sure that you use units. Okay, so they want to fly to Katajuta, which is 25 kilometers from Uluru. How long in minutes will it take them to fly there? Sorry, I just actually totally blanked for a second, really possible. So what we're looking for here is long, which is time. So we're going to use our distance formula again. So speed equals distance over time, meaning let's cover up time. Look at where the other two are. It's distance over speed. So the distance is 25 kilometers over, what is the speed? 250 kilometers an hour. What is that in a calculation? It is 1/10, or we can write 0.1, and that will be in hours. Now, in order to transfer it from hours to minutes, not to seconds, we need to do a conversion of 60. So to go from hours to minutes, how many minutes are there in an hour? There's 60. And there's more minutes than there are hours, so we're multiplying, we're timesing. So it's 0.1 times 60, and that will give us, move the decimal place across 6 minutes. So this one here may be also a bit tricky, because the hours to seconds conversion, kilometers per hour and meters per second conversion, you know that's a 3.6, but this one required you to understand there's 60 minutes in an hour. So yeah, again, simple, but takes a bit of thought. Okay, next one. Miss Fanning doesn't want to fly a plane. The distance she's traveling by road is 50 kilometers. So that's her distance. The time here is 54 minutes. Okay, so you don't actually need to use a formula for this one. What we're trying to show is that if we're traveling 54 kilometers over 54 minutes, that's basically saying 1 kilometer per minute. That is a true thing to say, but whenever we're giving speeds, we've got to give meters per second or kilometers per hour. That is our natural convention. So if every minute you go 1 kilometer, that means in 1 hour, 60 mins, meaning the speed here is 60 kilometers per hour. Okay, so just a little bit of common sense there. All right, so she's clear. Then we've got a force, mass, acceleration one. So here's the mass. Here's our deceleration. So deceleration is 20. Deceleration negative. Calculate the force exerted by the car in the ditch. Okay, let me apologize. Let me take out the negative sign, because it's not going to be appropriate. We're not going to have negative force here. The force equals mass times acceleration. Force equals mass, 1100, times acceleration. And let's make sure that they're both in the right units. Force is in newtons, mass has to be in kilograms, and acceleration has to be in meters per second. So in this case, it's going to be 1100 times 20. So it's going to be 20 to 100 newtons. Make sure you have newtons at the very end. Always give units. Always underline your final answer for all the mathsy ones. Okay. So next we have, what have we got here? We've got a mass of 130 kilograms, a height, we're a helicopter. So we're going to call that a height of 1500 meters. And what are we trying to find? Their potential energy. So potential energy here is simply mass times the gravitational force, a constant, which is always 9.8. And all I've done to find this formula is look at my formula sheet times height. So it's 130 times 9.8 times a height of 1500. And let's make sure they're all in the right units. Yes, mass is in kilograms. Yes, height is in meters. Let me just calculate. So this answer is 1,911,000 joules. We can say 1,911 kilojoules. Either one of those would be correct. Kinetic energy, what's that? Is mass times velocity squared over 2. And so this particular formula tricked up a lot of us. We've got to have the mass times velocity squared. So it's going to be mass times velocity times velocity. That's basically what we're doing. And then all of that divided by 2. So the velocity here, oh, okay. So the kinetic energy as they touch the ground. So this is, we don't actually need to use a kinetic energy formula. It's actually one of those ones that are based on your test. So the idea here is that the potential energy at the start of their jump, at that 1500 meters, by the time they hit the ground, will have all been transformed into kinetic energy. Why is this? Okay, so for potential energy, we need height. Say I have this pen up here. It has a height of whatever. Let's call it 100 joules of potential energy. It hasn't started to move yet. It's from a height. As it's falling, so say we're watching in slow motion, as it's falling, it has less height, therefore less potential energy. Okay, so it's got less potential energy than it was up here. But we know that energy is not created or destroyed. It has to be transferred or transformed. What is it transferred or transformed into? Kinetic energy. So as the object loses height, that energy is transformed into kinetic. And the idea is that as it's reaching the ground at 0 height, so not stationary, as it's reaching the ground at 0 height, the entirety of the potential energy is now kinetic. So yeah, that is that one there. Okay, so let's have a look here. So the maximum speed of the car, so perfect. Let's go into number C. The max speed of the car, well, this is a simple time versus speed graph, not distance, speed. So we know that the max speed of the car is 20. And let's make sure we use the units from the graph, meters per second. Use the graph to calculate the acceleration of the car during the last 30 seconds of motion. Okay, so acceleration is, it's sort of like a speed formula, but it's change in distance over change in time. So what we're looking for here, so change in speed versus change in time, is the final speed minus the initial speed over the same thing with the time final over time initial. So basically the endpoint versus the start point. You may get a negative answer for this. So what we're looking for here, so let's have a look at this graph. So we're looking at the last 30 seconds. So the final speed, let's call that speed final here, is 0. We're at 0. Perfect. The final time, the final time here is 100. Okay, so that's the thing. And this is the initial, because we're looking at the last 30 seconds. We're just looking at this part of the graph here. Okay. So for that point here, sorry, there's someone as well. Okay, and the initial speed, so speed initial is 20 and time initial is 70. So we're just going to put those numbers into the formula. Okay, so exactly as it reads. So on the top, we have final speed minus initial speed. So that is 0 minus 20 over final speed minus initial speed. That is, sorry, nothing, 100 minus 70. So that's going to be negative 20, yes, over 30. Negative 2 over 3 is going to be negative 0.6 recurring. And that's going to be in meters per second squared. With something like this, follow the question exactly as it appears. Yes, you get a negative answer, and the reason why is because it's decelerating. As we can see from the graph, they're going from a top speed of 20 and slowing down to 0. Okay, so I've just redrawn the graph really crudely down here. To find distance when we are looking at a speed versus time graph, what we actually need to do is find the area. So what I'm going to do is do that down the bottom in this little section here. Okay, so I'm just going to partition up this shape into 3 more manageable shapes rather than a silly trapezium. If you remember the formula for a trapezium, great, but if not, just use triangles and whatever they call them. So, okay, so this is triangle. The formula for triangle is base times height over 2. The base is 10, the height is 20 divided by 2. 10 times 20 is 200 divided by 2. Area equals 100 units. Let's do the rectangle. So the area for a rectangle, really simple, is length times width. So the length going across between 10 and 70 is 60. The width or the height or whatever the other thing is 20. So that's going to be 1200. And then the last thing here, so area again for a triangle, base height over 2. Base between 70 and 100 is 30. Height for 0 and 20 is 20 over 2. So that's 600 divided by 2 equals 300. So we add all that up together. 100 plus 1200, 1400 plus 300 is 1600 meters, I believe. Yes, it was meters per second. So just showing any sort of working out there would have gotten you the marks. Yeah, tricky question there. Oh my God, we're almost at the end. Oh my God. Okay, so last question, what are we doing now? So we're looking at this law of motion that's relevant here. So it's basically you're suddenly stopping in a car and the seat belts pull you back. So the idea here is that you're traveling in a car and then there's a force that reacts with you, the passenger and the car. And without the seat belts to stop you, you would keep moving. So this is actually all about inertia. Yes, force and acceleration comes into it. Force and acceleration will increase, acceleration mass will increase the force. But the idea that if there was no seatbelt, no external force against you, you would continue moving through the car. So that's why seatbelts are so important, because otherwise we just go straight through the windshield. So what I need to say is inertia. I don't need to explain it yet. Explain how this motion has resulted in. So, include a definition. Okay. Inertia is the tendency for an object to resist a change in motion, something along those lines, to resist a force, an external force, etc., etc. I would say the passengers would continue to move forward without the seat belts resisting this motion. Okay, and I think we are done, Julian. Thank you for sticking with me. That was really, really long. Thank you. If you have any more questions, please contact me or any of the other Year 10 science teachers or whoever. Happy to do so. Thanks for waiting. Thanks for putting up with this. Bye.